Hello everyone, I am Ashit PV. Studying in Achieving Kashmir College of Engineering. Today I am going to give a seminar on a review on machine learning styles in computer vision techniques and future directions. Mm, First of all, introduction. I'm gonna tell you about the machine learning. Machine learning is a branch of artificial intelligence that involves training computer systems to learn from the data and improving their performance and prediction and analysis of the data. Machine learning in computer vision can be divided into three categories: traditional and deep learning and hybrid. Hybrid is nothing but which the combination of traditional and deep learning. Traditional machine learning techniques in computer vision include algorithms such as decision trees, support vectors machines, and k nearest algorithms, etc. Deep learning techniques, on the other hand, use neural networks to automatically learn features from visual data. Hybrid machine learning techniques are the is the combination of the strengths of both the traditional machine learning and the deep learning. Um, for example, visual data automatically deep learning to use the visual data automatically, then and to use traditional machine learning algorithms to make predictions based on the features. And the importance of the machine learning in computer vision is significant and enabled as many. And these some of the importance of the machine learning in computer vision or automation of visual tasks. Machine learning algorithm in computer vision can automate a range of visual tasks such as object detection, segmentation, recognition. And another importance of machine learning is improved accuracy and speed. Machine learning algorithm can process large amount of visual data much faster with higher accuracy and humans, leading to improved efficiency. Better decision making. Machine learning can use can learn patterns and make predictions based on visual data that can help humans make better decisions. Unsupervised learning. Unsupervised learning technique enables the discovery of new patterns and insights in visual data. These are some of the importance of machine learning in computer vision. And coming to the next, the complete overview of traditional machine learning techniques. Traditional machine learning techniques in computer vision involve the use of algorithms that require manual feature engineering. These algorithms rely on predefined features which are typically handicraft by experts in the field. Here are some of the examples of traditional machine learning techniques in computer vision. Firstly, decision tree. Decision tree are a popular machine learning algorithm used in computer vision. They're used to classify images based on predefined and can be used for tasks such as objects recognition and scene class. Support vector machine. This is another popular machine learning algorithm used in computer vision. They can be used for tasks such as object recognition and image classification, etc. SVMs work by finding the hyperplane the best to separate. The best is the first, which is the rule that follows the support vector machines. And random forest are machine learning algorithm that combines multiple decision trees to get an accurate predicted output. And k-nearest neighbors is a simple machine learning algorithm used for image classification. It works by finding the k-nearest neighbors to a given image and assigning the image to the class. This is the sum of the overview and uh, use it for support vector. And coming to the overview of deep learning techniques in CB computer vision, that is computer vision. Deep learning techniques have revolutionized computer vision by enabling the automatic extraction of features from visual data. Deep learning algorithms are artificial neural networks with multiple layers to learn hierarchical representation of the data. Hierarchical representation is that which can be which can be getting read by the different kind of data to get an accurate analyzation or the prediction of the data. Some examples of deep learning techniques in computer vision are convolutional neural network, CNN, RNN, which is recurrent neural networks, and generative adversarial networks, and autoencoders. These are some of the examples of deep learning techniques. Coming to application of deep learning techniques, which is included in the overview of deep learning techniques in CP. Image classification is another application of deep learning in computer vision techniques. Image classification. Image classification is nothing but particularly convolutional neural network, have achieved state-of-the-art performance in image classification tasks. Image classification task involves image a label to an image, which can be a different labels to each image of particular kind of objects. And similar to that, object detection is another application of deep learning. Object detection is nothing but identifying the location of the class of the object within an image or a video. If, for example, if a particular video or the image displayed, the object or the data is particularly mentioned and detected of the location of the in the image is known to be the object detection. Um, Application of deep learning is image generation. Deep learning techniques such as generative adversarial networks (GANs) can be used to generate new images that are similar to given dataset. If, for example, a certain dataset is given, so similar to that dataset, the new images can be generated using GANs in image generation. And medical imaging deep learning technique have been applied to medical imaging tasks such as lesion detection, tumor segmentation, and disease diagnosis. Deep learning method models can learn to detect subtle patterns in medical images that are difficult for humans to detect. Autonomous vehicles. Deep learning techniques are used in development of autonomous vehicles for tasks as an object detection or lane detection or pedestrian detection or emission testing or these are the autonomous vehicles which can be used where the deep learning is used in this kind of application. Next, the advantages of deep learning is high accuracy, feature extraction, generalization, scalability, transfer learning. These are some of the advantages of deep learning, where high accuracy refers to um, accurate of that prediction or the analyzation of deep learning techniques, and feature extraction is another advantage where future can be predicted or analyzed from the feature extraction. Generalizing scalability transfer learning, or these are some of the just or the advantages can underwent under the deep learning. Next, hybrid machine learning, where the combination of, as I told us, combination of traditional machine learning and deep learning. Ensemble methods combine the predictions of multiple models to improve the accuracy and reduce overrating. A popular ensemble method in computer vision is the use of ensemble of deep learning models with different architecture or trained of different subsets. Active learning involves selecting the most informative samples to the label for training a model. It can reduce the amount of label data required. And these are the some of the applied in various domains of hybrid machine learning. And hybrid machine learning is applied in medical imaging, surveillance and security, natural language processing, and etc. And some of the advantages of hybrid machine learning techniques in computer vision are improved performance. Performance can be improved compared to other or the previous performances, and reduce the data requirements, where data is reduced to some extent and can be made to predict in an accurate way or analyze in an accurate way. Flexibility, where the data can be flexible for the prediction, robustness, etc. And coming to emerging trends in machine learning in computer vision, where emerging trends in machine learning in computer vision are self-supervised learning. Self-supervised learning involves training models on pretext tasks using unsupervised data, and then fine-tuning the model on the target task with level data. Self-supervised learning can reduce the need for large amount of labeled data, and shown shown in such as image classification and object detection. Generative models is an emerging trend in computer vision. In machine learning computer vision, generating models such as generating adversarial model networks and variational autocommanders are becoming increasingly popular for tasks such as image um, synthesis and data argumentation. GNs can be used for realistic images for noise. Well, VAS can be used for the unsupervised feature learning, and these are the emerging trends in machine learning and computer vision. To the next, another emerging trend is attention mechanism. Attention mechanism can help models focus on important features or often images, where the images is which where images can be focused on improved performance on tasks such as image classification, object detection, etc. Attention mechanisms can also be used to visualize the areas of an image that a model is focusing on. Explainability and interpretability mm, is another emerging trend in the machine learning of computer vision. Um, Overall, the emerging trends in the machine learning in computer vision have the potential to improve performance, reduce data requirements, and increase integrity of models. And some of the challenges where the when there is an emerging trends or the machine learning have techniques have becoming a new trends, there might be some challenges also with new trends or the opportunities in machine learning. Well, these are some of the challenges regarding machine learning in computer vision regarding to the emerging trends of machine learning in computer vision. Data bias. Computer vision models can be biased if they are trained on data that does not represent the full range of variation in the real world. And another challenge is lack of interpretability. Deep learning models can be difficult to interpret, which can make it challenge to understand. And overfitting. Deep learning models can be prone to overfit if they are trained on the insufficient, poorly diverse data. Computational requirements as another challenge. Deep learning net models can be computationally expensive, which can make it challenging to train and deploy them on resource constrained devices. These are some of the challenges and opportunities in machine learning in computer vision. Opportunities, especially in machine learning in computer vision, are advancements in hardware, the development of specialized hardware such as graphics processing units and tensor processing units has made it possible to train and deploy deep learning models. Increase in available data. With the growth of digital technologies, there is an increased amount of data available which can be used to train and improve computer vision models. And overall, well, these are the challenges in machine learning, computer vision. There are also significant opportunities for the advancement of real world applications. And coming to the future directions of research in machine learning and computer vision, the field of machine learning in computer vision is constantly evolving, and there are several directions for future research. Here are some of potential areas of research: robustness and reliability. This is one of the future direction of research in machine learning in computer vision. Robustness, improving the robustness is a focus of readily focusing on the data interpretation. It is a critical area of research. Models need to be able to handle variations in lighting, occlusions, and other challenging conditions to be effective. And federated learning is another future direction. It is a distributed learning technique that enables models to be trained or decentralized data. And another and And finally, coming to the conclusion of machine learning in computer vision is it is a future of computer vision as it allows for the development of models that can accurately and efficiently analyze visual data. Machine learning models can be designed to run in real time, enabling real time analysis of visual data. It is particularly important for applications such as self-driving cars where decisions need to be made quickly based on visual information. Overall, machine learning is critical for the future of computer vision as it enables the development of models that can accurately and efficiently analyze visual data and in a variety of domains. As the field of machine learning continues to advance, we can expect to see even more exciting applications of the future. And and thank you for the giving me this opportunity and having time for me to explain or giving the seminar of the topic regarding machine learning in computer vision. Thank you.